Welcome back. In this video, we're going to look at a number of 0 over 0 sorts of limits, and just look at the kind of techniques that come up and end up being useful in solving these limits. Okay, so here's a typical one. We've got some quadratic over some other quadratic, and when we plug in 3, we get 3 squared minus 3 minus 6, which is, lo and behold, 0. And you'll get 3 squared minus 30 plus 21. That's approximately 0. Okay. And so we end up in the 0 over 0 flavor, which is maybe not surprising given it was literally in the title. And once we have the 0 over 0 flavor, what is it we have to do? We have to try and do some algebra to clear that up. So that is, I'm going to rewrite this. The limit as x goes to 3. And I'm going to factor the numerator and denominator. So the numerator here becomes x minus 3 times x plus 2. And the denominator becomes x minus 3 times x minus 7. Now, we saw what we're hoping to see. We found a common factor. And so we can cancel this common factor. And so now this will become the limit as x goes to 3 of x plus 2 divided by x minus 7. Okay. And now when I look at this piece is now going to be about 5. This piece is going to be about minus 4. And so this final value of this limit is going to be minus 5 over 4. Again, I want to remind you, every time we have one of these 0 over 0 flavor limits and it works out to some number at the end, what that means really is that there was a hole in the graph and we just fixed it. Okay, in other words, we've got something like, here's 3. Our graph is something like this. Where here is 3, and here is minus 5/4. So we figured out that, hey, if you just plug in this hole, then the value of the function you get at 3 is minus 5/4. That's what we figured out. Okay, here we have another limit. And this limit, again, has that 0 over 0 flavor, because if I plug in 4 here, I'd get 8 over 4, which is 2. 2 minus 2 is 0. And also, 4 minus 4 is 0. Whoops. So that means we have to, again, try and factor stuff. In this instance, we have fractions inside of fractions, so before we can really hope to improve ourselves and improve the situation, we have to first rewrite this as one fraction so there's not a fraction inside the fraction or whatever. Okay. And so I'm going to do this by doing two things. One is I'm going to realize the denominator here I can really write as x minus 4 over 1, and dividing by that is the same as multiplying by 1 over x minus 4. And then I'm going to put this piece over a common denominator of x. And when I do that, I'm going to get an 8 minus 2x. Again, what did I do? I flipped the fraction in the denominator over, and I wrote this thing in the numerator over a common denominator. So I can now multiply this, so 1 times that's going to be the same thing. And I'm going to get x minus 4 times x in the denominator. And things are starting to look a little bit better. Okay, now I do have to try and do some factoring. Namely, it would help me if I factored a minus 2 out of the numerator here. Okay, if I factor a minus 2 out of a minus 2x, I'm left with an x. if I factor a minus 2 out of an 8, then I'm left with a minus 4. Okay. And that's all divided by x times x minus 4. Now, we're almost done because there's these two x minus 4s, but I just want to make a note in case you did not like me saying factor a minus 2 out. You can also look at 8 minus 2x and say, aha, I want to factor a 2 out of that. And when I factor a 2 out of that, I get 2 times 4 minus x. And this 4 minus x is the same thing as x minus 4, but backwards, which is where you use our trick from a few videos ago, that if you have an a minus b, that's the same thing as minus b minus a. Okay. So either way you look at this, whether you look at it this way or this way, you end up in the same place where you've now got this x minus 4 in the numerator and denominator. So I can cancel those. And notice, I know this is good because the x minus 4 is what's making the numerator 0 when x is 4, and ditto the denominator. And so what I'm left with is just the limit as x goes to 4 of minus 2 over x. And that'll be minus 2/4, which is minus 1/2. That'll be our answer. All right, I'll wrap up this video here for now. In the next video, we're going to talk about doing limits that have radicals in them. That is, limits that have square roots somewhere floating around in the limit. But that's it for now. I'll see you next time.